Welcome to the Pro Ticker Deep Dive.
It's great to be here for this one.
It really is, because it is March 2026, and we were standing right at the precipice of just a massive structural realignment in the tech world.
We absolutely are. We are officially entering what the industry is definitively calling the Agentic era.
Right, the Agentic era. Because for the last few years, the entire world has been absolutely captivated by chatbots.
Yeah.
You type a prompt and it gives you a recipe.
Or a block of code.
Exactly, or a poem in the style of Shakespeare. It was revolutionary, sure, but fundamentally it just talked.
Right. It was a conversational parlor trick on a grand scale.
But right now, this very month, the paradigm is shifting violently from software that just talks to autonomous agents that actually do.
It is a profound transition, and it's happening much faster than most enterprise roadmaps anticipated. We are moving from the realm of digital assistants that require constant step-by-step human hand-holding to autonomous digital workers. These systems are being granted agency. They are being given the keys to the car, capable of multi-step reasoning, executing complex workflows across different applications, and making decisions in real time without you sitting there waiting to hit the enter key.
And that shift is, well, it's the foundation of our mission today.
Absolutely.
Because the most dominant artificial intelligence hardware company on the planet, a company currently valued at nearly $4.6 trillion, is quietly orchestrating what might be the most brilliant Trojan horse software strategy in the history of Silicon Valley.
It's brilliant. They are preparing to essentially give away the keys to this new agentic kingdom to maintain their hardware empire against a rising tide of custom silicon threats.
Right. And whether you are an institutional investor managing a multi-billion-dollar portfolio, a developer writing code in your basement, or just someone sitting in a corporate office trying to future-proof your career against the incoming wave of automation, understanding this pivot from hardware dominance to agentic software ecosystems is absolutely critical.
You cannot afford to be blind to this transition.
No, you really can't.
To truly grasp where the software is going and why this specific software strategy is so disruptive, we first have to ground ourselves in the sheer financial and physical gravity of the hardware infrastructure that makes any of this possible.
Let's do it.
Because the numbers we are looking at in the broader market right now are, quite frankly, difficult for the human brain to properly contextualize.
I mean, I'm looking at the ticker right now, and the financial fortress we are talking about is NVIDIA.
Right.
The stock is hovering right around $185 a share. That gives them a market cap brushing up against 4.4 to 4.6 trillion.
Trillion, with a T.
With a T. Let that sink in for a moment. There are serious market analysts actively predicting this will be the first $6 trillion company in human history.
It's staggering.
So help me make sense of this. Are the fundamentals actually supporting a number that large, or are we just riding the crest of the greatest hype cycle of the 21st century?
Well, if you look strictly at the fundamentals, specifically their fourth quarter 2026 financials, the valuation starts to lose its aura of irrational exuberance. Okay. They posted $68.1 billion in revenue for a single quarter.
Wow.
That is a 73% increase year over year. And the engine driving that entire train is their data center revenue, which accounted for $62.3 billion of that total.
So they are not making their money on gaming graphics cards anymore.
Not at all. They are powering the global cloud. And looking ahead, they are guiding for $78 billion in the first quarter of 2027 alone.
That is just massive.
But the most critical metric, the number that every single analyst hyperfixates on, is their gross margin. They're doing all of this while holding on to an exceptionally strong gross margin of 75.2%.
Wait, 75.2%?
Yes.
So for every $100 of product they sell, it only costs them about $25 to actually make it.
Exactly.
That kind of margin on physical hardware seems almost illegal. Usually you only see margins like that in pure software businesses with zero marginal cost of reproduction.
It's historically unprecedented for hardware at this scale. Those margins are the true, undeniable indicator of their current monopoly power. When a company can sell tens of billions of dollars of a physical product involving highly complex global supply chains, rare earth materials, and cutting-edge fabrication, and keep over 75% of that as gross margin, it means the buyers have absolutely no alternative.
They have over a barrel.
The pricing power is absolute. And the buyers in this case are the hyperscalers.
The cloud giants.
Exactly. We are talking about the massive cloud providers, Microsoft, Amazon, Google, Meta. The big four hyperscalers alone are locked into spending $650 billion on capital expenditures in 2026.
$650 billion
Yeah.
in 1 year.
Yep.
That's the GDP of a mid-sized European country just being poured into server racks.
And that is just the immediate horizon. The projections moving forward are staggering. By 2030, global data center capital expenditures are expected to rise to between $3 and $4 trillion annually. We are seeing estimates from major consulting firms, including McKinsey, pointing to a cumulative $7 trillion needed just to fulfill the expected global demand for AI compute by the end of the decade.
It is like the Industrial Revolution, but compressed into a few years.
That's a great way to look at it.
If you think about it, they aren't just selling the steam engines. They are selling the entire factories that power the future. They are literally manufacturing the physical infrastructure of the next economy.
That is exactly the framework you have to use. But the valuation paradox here is what catches so many traditional investors off guard. This is a stock that has grown over 1,100% in the last 3 calendar years.
Right, and that is exactly why human intuition screams that this must be a bubble.
Sure.
You see a chart that goes up and to the right that aggressively, and your brain just assumes it has to crash. I mean, 1,100% growth, and they are valued at almost $5 trillion. How is that not wildly overvalued? What is the market missing here?
What the casual observer misses is the forward price-to-earnings ratio, the forward PE.
Okay, break that down.
The forward PE is the metric that strips away the historical price action and factors in the expected earnings over the next 12 months. Right now, despite that 1,100% run-up, NVIDIA is trading at a forward PE ratio of roughly 22 to 25.
Okay, give me some context for that. Where does the rest of the market sit?
The S&P 500 average right now is 21.9.
No way.
Yes. So the broader market is valuing this hyper-growth $4.6 trillion monopoly as if it were just an average run-of-the-mill participant in the economy.
That's insane.
To put that in sharper perspective, let's look at classic value stocks, companies you buy for stability, not explosive growth. Coca-Cola is currently trading at 24.9 times forward earnings.
Wow.
Apple is sitting at 32.3. Costco is at 48.9.
Are you kidding me? Costco is at 48.9.
The math doesn't lie.
You are paying a higher premium for a share of Costco's future earnings than you are for the company building the physical infrastructure of artificial intelligence.
Exactly.
You're paying more for hot dogs and bulk paper towels than you are for the chips running the global AI revolution. That is absolutely wild.
It is counterintuitive, but you are paying a steeper price for the perceived safety of retail consumer staples than you are for the foundational layer of the agentic economy. And highly sophisticated institutional money is clearly doing this exact same math.
Right. They're seeing the underlying value.
Consider the recent maneuver by BSN Capital Partners. This is a fundamentals-driven firm based in London. They are notoriously conservative.
Right. These aren't meme stock day traders.
Not at all. They rely on rigorous discounted cash flow models. And they just disclosed a $463 million bet on NVIDIA. That single position now makes up 20% of their entire portfolio.
20%.
Yes.
When a conservative institutional asset manager allocates 1/5 of their entire war chest to a single stock that has already run up 1,100%, that sends a massive signal.
A huge signal.
They're putting their neck on the line for this. What does that actually tell us about the institutional mindset right now?
It signals profound institutional conviction that the infrastructure build-out is still in its early innings. Firms like BSN Capital are looking at the $650 billion in hyperscaler spending locked in for 2026. They are looking at the massive order book NVIDIA already has fully booked through 2025 and 2026. They have fundamentally concluded that this AI infrastructure build-out is not a temporary cyclical spike.
It's not a fad.
It is not a software trend. It is a multi-decade secular shift in how human computation is generated. They are entirely willing to stomach any short-term macro volatility because the underlying demand for the compute power is structurally insatiable.
But as impressive as the financials are, they only tell us where we are today and maybe where we are going in the next few quarters. The financials are a lagging indicator of the technology.
That's very true.
The real excitement, the stuff that is going to dictate the actual capabilities of these agents over the next 5 years is what is about to be unveiled next week.
The hardware horizons.
Yes. We have the GPU Technology Conference, or GTC, kicking off in San Jose from March 16th through the 19th. CEO Jensen Huang is giving his highly anticipated keynote.
Everyone is watching this.
And the entire industry is bracing for the official full-scale transition from the current Blackwell architecture to the upcoming Vera Rubin platform.
The transition to the Vera Rubin architecture is a pivotal moment, primarily because of what it demands from the physical world. It represents a massive upgrade in performance per watt.
Which is huge right now.
Power consumption is currently the single largest bottleneck for data centers globally. They literally cannot draw enough electricity from local municipal grids to power these massive AI clusters.
Right, they're looking at reopening nuclear plants.
They are exploring nuclear power just to keep the lights on. The Rubin platform is designed to aggressively address that efficiency crisis. However, Vera Rubin forces a highly disruptive infrastructure upgrade. The new platform requires an 800-volt power infrastructure to operate.
And that is not a trivial detail. This isn't just a simple chip upgrade where you pull a server rack out, pop out the old processor, snap in the new one, and turn it back on.
Yeah.
An 800-volt requirement sounds like you have to tear the building down to the studs.
That is an apt description. It forces data centers to fundamentally re-architect their physical environments. Standard legacy data centers operate on much lower voltages.
Right.
To safely and efficiently support an 800-volt system at this density, you have to rip out and replace entire power delivery networks. You have to update the liquid cooling loops because air cooling is entirely insufficient for this thermal output.
Wow.
You have to entirely overhaul the networking setups to handle the data throughput that these chips demand. And this highlights the hidden brilliance of their business model.
Because they sell all of that stuff, too.
Exactly. They don't just sell the GPU, they sell the networking gear. The NVLink interconnects the specialized, switches the entire rack-scale system. The 800-volt requirement is a massive forced pull-through revenue generator.
That is so smart.
By upgrading the core silicon, they force the customer to buy a whole new suite of supporting infrastructure, which they conveniently also manufacture and sell at high margins.
It's an ecosystem upgrade, forced by the absolute laws of physics and electricity. You want the new brain. You have to buy our new nervous system, our new circulatory system, and our new skeleton to support it.
That's perfectly stated.
And speaking of ecosystem upgrades, we also have to talk about the multi-billion-dollar licensing agreement that was just finalized with an AI chip startup called Grok. G-R-O-Q for anyone taking notes.
This is a huge development.
They are incorporating Grok's high-speed SRAM-based inference capabilities into their new server systems. I want to dig into this because for the last few years, all we heard about was training the model, scraping the internet. Now suddenly Grok is the hottest name in the room. Why is inference suddenly the new battleground?
To understand the significance of the Grok integration, we have to clearly define the difference between training an AI model and inference.
Okay, let's do it.
Inference is the act of actually running the model once it's built. NVIDIA's existing chips, like the H100 and the Blackwell line, are the undisputed kings of training.
Right.
Training involves processing massive petabyte-scale data sets to teach the model how to think and recognize patterns. These chips use high-bandwidth memory, or HBM. HBM is fantastic for moving massive, heavy chunks of data relatively slowly.
Like a massive cargo ship.
Exactly. But inference is entirely different. Inference is what happens when you, the user, actually asks the model a question, and it has to generate an answer in real time. Grok recognized that inference didn't need the heavy lifting of HBM.
So what did they do?
They developed a completely different physical architecture using SRAM static random access memory.
And what's the tangible difference there?
SRAM doesn't need to constantly refresh its data state like other memory types. The data is just immediately available. It is incredibly fast, allowing models to generate hundreds, sometimes thousands of tokens per second with ultra-low latency.
Okay, I see where this is going.
Now, if we connect this to the rise of autonomous agents, latency becomes the ultimate enemy. A traditional chatbot just streams text to your screen. If it takes a second to start, you don't really care.
Right. You just watch the cursor blink.
But an autonomous agent isn't just generating a single text response. It might be executing a loop of 50 internal reasoning steps, querying a database, reading a document, writing a Python script, testing that script, realizing it failed, and rewriting it all before it ever shows you a final result.
Right, it's doing a whole workflow behind the scenes.
If each of those internal reasoning steps takes 3 seconds of compute time on standard hardware, a complex task might take 10 minutes to resolve. The agent becomes unusably slow for real-time business applications.
Nobody wants to wait 10 minutes for a task.
Exactly. Grok's SRAM technology provides the instantaneous millisecond inference speed required to make complex multi-step agentic reasoning viable in a fast-paced production environment.
I see. So it's essentially the difference between a freight train and a bullet train.
That's a great analogy.
You absolutely need the freight train to haul the raw materials, to build a model in the first place. But once the model is built, you need the bullet train to actually deploy the agent and have it zip around your corporate network in real time.
Completely.
Now, that bullet train inference speed isn't just a corporate advantage. It's increasingly viewed as a matter of national security.
Oh, absolutely.
Which brings us to the geopolitical elephant in the room. The United States government recently approved the export of the H200 system to China, but it came with a massive, highly punitive string attached, a steep 25% export tax.
The China export tax is a fascinating geopolitical variable, and it introduces a complex layer of game theory into their global strategy.
Let's unpack that.
China represents a massive, structurally vital portion of the global AI market. However, NVIDIA has been largely locked out of selling their most advanced chips to Chinese tech giants due to escalating U.S. export controls over the last 2 years.
Right. Washington has been very protective.
The approval of the H200, even saddled with a 25% tax, reopens that critical door. But the strategic speculation now centers entirely on how the company will manage that sudden margin hit.
Right, because 25% is not a rounding error. That is a massive chunk of change. So what are their options? Do they just eat the cost?
They have two distinct paths. First, they could choose to absorb the 25% cost themselves to rapidly regain market share. Remember, domestic Chinese silicon competitors, most notably Huawei with their Ascend chips, have been aggressively filling the vacuum left by U.S. export bans.
So if they eat the tax, they can compete on price.
Right. If NVIDIA absorbs the tax, their gross margin on those specific Chinese sales drops from 75% down to roughly 50%. But it allows them to undercut Huawei and reestablish their hardware as the default standard in Chinese data centers.
Then what's the second path?
The second path is to pass that 25% premium directly on to the Chinese hyperscalers. Alibaba, Tencent, Baidu.
Just make them pay for it.
This strategy bets that the sheer computational superiority of the H200 and its integration with their software ecosystem makes demand so inelastic that these companies will simply pay whatever premium is required to stay competitive globally.
Given their overall 75% gross margins, they certainly have the financial shock absorbers to eat that tax if they decide aggressive market penetration is more important than short-term profitability.
They absolutely do.
And honestly, looking at how they operate market dominance usually takes precedence.
Usually, yes.
But let's pivot and bring this back to the software, to those inference speeds we talked about to Grok. Because all of this hardware, all of this geopolitical maneuvering, the massive data center retrofits, it is all in service to one specific thing.
The software.
The new type of artificial intelligence that is currently taking over the world, the paradigm shift from chatbots to claws.
This is where it gets real.
We have been living in the era of large language models, or LLMs, for a few years now. You ask the LLM a question, it generates a response. It operates in a highly constrained, isolated sandbox. It has no memory of what you asked it yesterday, and more importantly, it has no ability to reach out and actually do things on your computer.
It's totally disconnected.
But now the industry has successfully birthed autonomous AI agents. And the colloquial term that has absolutely caught fire in Silicon Valley for these specific, highly capable agents is claws.
The distinction between a traditional LLM and a claw is critical to grasp as it fundamentally changes the risk profile of the technology.
Let's talk about that risk profile.
An LLM performs single-step content generation. A claw features multi-step reasoning. But the true differentiator is that a claw has native system access.
System access, that's the key.
It can set its own sub-goals, achieve them, manage long-term state and memory, and operate for hours or even days without any continuous human supervision or prompt pushing.
Yeah, when we were first researching this, a lot of people were using this analogy of an intern versus a librarian. But honestly, knowing how you all understand software architecture, I think we need to upgrade that analogy. A traditional LLM is basically like a sandboxed guest user account on your operating system. It can read some files if you explicitly give them to it. It can write a document, but it cannot execute programs. It cannot change system settings. It is structurally isolated from the core machinery.
Right.
An AI claw, on the other hand, is basically granting your AI root access to your entire digital infrastructure. You're giving it the administrative credentials to open applications, read databases, execute scripts, send emails, and modify files across your entire network. It is incredibly powerful. but it requires a terrifying level of trust.
But root access is the perfect way to frame it because it perfectly encapsulates the profound risk of granting agency to probabilistic models. And the tech world saw this play out in real time very publicly with the viral story of OpenClaw.
Oh man, the OpenClaw story.
OpenClaw, which was previously known in developer circles as ClaudeBot and Moltbot, was built by a lone developer named Peter Steinberger.
Just a guy in his basement.
Exactly. It was an open source agent designed to be installed locally on a personal computer. It captivated the industry because, unlike previous theoretical models, it actually worked reliably.
It really did.
It could seamlessly browse the web, write complex code, interact with standard desktop applications, and perform lengthy sequences of tasks entirely on its own. It was so undeniably impressive that OpenAI swooped in, acquired the entire project, and brought Steinberger in-house.
It was the ultimate Silicon Valley Cinderella story.
Yeah.
A solo dev built something amazing, gets the golden ticket.
It was.
But that same software also exposed a massive, terrifying dark side to this new agentic era.
Yes.
Because when you give experimental software root access to your office life,
Yeah.
things can go horribly, catastrophically wrong.
They certainly can.
There was a highly publicized incident involving a safety researcher at Meta. She had an instance of OpenClaw running locally on her work machine to test its capabilities.
Right.
Due to a slight hallucination in its reasoning loop, a misunderstanding of its instructions, and totally unchecked system access, the agent went rogue.
It was a disaster.
And it didn't just crash. It systematically mass deleted her entire archive of corporate emails. It just wiped years of communications out in seconds.
Unbelievable.
Now, I mean, we've all stared at our screens on a Friday afternoon
Yeah.
and fantasized about just mass deleting our entire inbox and starting fresh.
We all have.
But having an AI actually do it for you without asking is a completely different level of professional stress.
It's a nightmare.
And this incident triggered a massive shockwave. It led to immediate sweeping corporate bans. Meta LangChain and several other major tech giants flat out banned their employees from installing or using OpenClaw on any work devices.
The Meta incident was a wake-up call. It perfectly highlighted what security professionals in the industry now refer to as the lethal trifecta of agent risks.
The lethal trifecta. Walk us through it.
First, you have unauthorized data access. Once an agent has local system privileges or API access, it can read sensitive HR files, proprietary source code, or unreleased financial records that it was never contextually supposed to see.
Right, it just wanders into the wrong digital room.
Second, you have unchecked external communication. If an agent can read a highly classified internal document and it simultaneously has open web access, it can inadvertently or maliciously, via a technique called prompt injection, send that sensitive data to an external server.
That's a massive data exfiltration risk.
Massive. And third, and perhaps most concerning, is the generation of harmful content or destructive actions. Deleting a single user's email archive is actually a relatively benign failure compared to an agent mistakenly modifying a live production database.
Oh.
Or triggering a massive automated financial trade based on hallucinated data, or altering physical supply chain orders in an ERP system.
So this brings us to the ultimate friction point. Every CEO, every chief operating officer in the Fortune 500 looks at the theoretical productivity gains of a claw, and they drool.
They want it.
They want that efficiency. They want a digital workforce that doesn't sleep. But absolutely no CEO is going to deploy a software tool that might randomly delete the legal department's inbox or leak their Q3 earnings report to a public server because it got confused by a spam email.
No one is taking that risk.
How do you bring the incredible world-changing productivity of autonomous agents into the enterprise without risking total corporate sabotage?
This is exactly where the $4.6 trillion hardware giant makes its move.
Into NVIDIA's software play, NemoClaw.
NemoClaw is NVIDIA's upcoming open-source AI agent platform specifically engineered from the ground up for the enterprise. It is a direct, calculated response to the security vacuum exposed by Wild West tools like OpenClaw.
So how does it actually solve that problem?
To understand why NemoClaw is such a significant leap forward, we have to look closely at its underlying Nemo architecture. It is not just a single application. It is a highly modular, deeply integrated ecosystem designed for control.
Okay, break down the layers for us.
At the foundational reasoning there, you have Nemotron 3. This is their state-of-the-art reasoning and tool calling engine. It is specifically optimized for the complex branching logic required by autonomous agents rather than just generating creative text.
Got it.
But the truly critical component, the piece that solves the CEO's dilemma, is Nemo Guardrails. This is a programmable safety and policy enforcement layer. It acts as a hard deterministic boundary around the agent probabilistic reasoning.
It's the bouncer at the door of the nightclub. It doesn't
Uh,
matter how confident the agent is. If it's not on the list, it's not getting through.
Precisely. Even if the Nematron 3 engine hallucinates or is actively tricked by a malicious prompt injection into deciding that the best course of action is to delete a customer email database, Nemo Guardrail steps in.
It intercepts it.
It intercepts the action before it executes, evaluates it against a set of hard-coded corporate policies, and blocks the execution entirely. It neutralizes the lethal trifecta by removing the agent's ability to act unilaterally outside of predefined bounds.
That is massive for enterprise adoption.
And beyond security, they've solved for deployment. They utilize NI microservices, which provides highly optimized container deployment. This allows enterprises to easily take these complex models and run them on their existing infrastructure with massive throughput without needing a team of PhDs to configure the servers.
Turnkey deployment.
Exactly. Finally, they include comprehensive observability tools. These provide real-time tracking, extensive logging, and cryptographic audit trails of every single action the agent takes or even attempts to take.
And it doesn't just stop at safe deployment, right? The system is designed to actually learn and get better over time. They have built this concept they call the data flywheel.
The data flywheel is crucial.
You use their ingestion tools like Nemo Curator and Data Designer to take all your messy, unstructured corporate data, your massive PDFs, your sprawling Slack logs, your years of customer service transcripts, and clean it up for the model.
Right, you feed the engine.
Then once the agent is running, you use Nemo Evaluator and Customizer to continuously monitor how the agent performs, gather human feedback on its decisions, and iteratively retrain the agent so it gets smarter and more efficient at your specific corporate tasks over time.
The data flywheel is the mechanism that transitions an agent from a generic off-the-shelf tool into a highly specialized, deeply integrated domain-specific worker. It becomes an expert in your company.
And frankly, the most telling aspect of NemoClaw isn't just the technical architecture. It is the aggressive business development strategy surrounding it. Ahead of the GTC conference next week, NVIDIA has been actively pitching deep native partnerships to major SaaS and cybersecurity giants.
This is the strategic masterstroke.
They are in advanced discussions with Salesforce, Cisco, Google, Adobe, and CrowdStrike. The CrowdStrike partnership makes so much sense when you really think about the mechanics of how an agent operates.
It does. Why is a premier cybersecurity endpoint firm like CrowdStrike essential to an AI agent platform? Because as we established with the lethal trifecta, autonomous agents represent a massive, entirely new cybersecurity attack surface.
Right.
If an agent is authorized to autonomously read incoming external emails and summarize them, a bad actor can send an email containing a hidden prompt injection.
Text that looks like gibberish to a human.
Right, but it acts as an executable command to an LLM. When the agent reads it, the injection hijacks the agent's logic, effectively turning the agent itself into a localized malware vector with root access. Partnering with CrowdStrike ensures that enterprise-grade endpoint protection and threat intelligence are natively integrated directly into the agent's decision-making loop.
They are locking down the endpoints at the agent level.
Exactly. And regarding the pitches to SaaS giants like Salesforce and Adobe, this is equally strategic. These companies operate on seat-based business models. They charge their clients per user per month. It's the lifeblood of their revenue. Yeah. But if third-party autonomous agents start doing the work of 5 human marketers in Adobe or 10 human sales development reps in Salesforce, those human seat licenses disappear. The revenue collapses.
The existential threat to SaaS.
By partnering directly with NVIDIA, these SaaS platforms can agentize their own software first. They can offer NemoClaw-powered secure agents natively within their own ecosystems, capturing the immense value of the automation and upcharging for agent seats rather than being disrupted by external bots.
It is absolutely brilliant corporate maneuvering. You save the SaaS companies from disruption by making them dependent on your AI layer.
Win-win for them.
But here is where the story gets really compelling. The most surprising aspect of NemoClaw isn't the guardrail security, and it isn't the SaaS partnerships. It's the fact that NVIDIA is making this incredibly powerful enterprise platform completely open source and totally hardware agnostic.
This breaks all their old rules.
Let's look at history for a second. NVIDIA built its multi-trillion-dollar empire on a very strict walled garden strategy, specifically with their CUDA software platform. CUD was the magic programming code that made AI run efficiently, and it only worked on NVIDIA GPUs. It locked developers in tight.
Very tight.
If you learned CAD in college, you bought NVIDIA hardware for your startup. Simple as that. But NemoClaw fundamentally breaks that rule. NemoClaw can run on competitor hardware. It can run on AMD chips.
Yeah.
It can run on custom ASICs, which, for those who might not deal with hardware daily, are application-specific integrated circuits, meaning chips physically hardwired by companies like Google or Amazon to do one specific math problem perfectly, rather than being a general-purpose processor.
Right.
Why on earth would a company with a near monopoly on hardware build a beautiful, free, open-source software platform that actively helps their competitors' chips run better?
This right here is the essence of the Trojan horse strategy. And it is a masterclass in economic lock-in.
Here's where it gets really interesting.
To understand the economics driving this decision, you have to look at the early benchmarking data. A recent comprehensive study involving PayPal demonstrated that utilizing the NeMo framework resulted in a 49% reduction in agent latency.
That's half the wait time.
And crucially, a 45% reduction in overall GPU operational costs. The framework is undeniably objectively efficient.
So they're giving away efficiency.
Yes. By making NemoClaw the open-source industry's standard free-to-use modify and deploy anywhere, NVIDIA is effectively salting the earth of the software layer. They are destroying the business models of any startup attempting to build a competing proprietary agent operating system.
They are making it free so no one else can sell it.
They are ensuring that the Fortune 500 builds their critical enterprise workflows on the NeMo orchestration layer. They are standardizing the operating system of the Agentic era before anyone else can monetize it.
So they are handing out the blueprints for the factory for free, knowing that they are the only ones who can efficiently supply the raw materials to keep the factory running.
That is precisely the play. Because they know that as enterprise adoption scales, as a massive corporation goes from testing 5 agents in a sandbox to deploying 50,000 agents across their global network, the computational demands will skyrocket exponentially.
Right, the hardware demands will be insane.
And yes, while NemoClaw can technically run on an AMD chip or an Amazon custom processor, the deep fundamental software optimizations within the NeMo ecosystem are naturally inherently tuned for NVIDIA's own physical hardware architectures.
Of course they are.
When performance bottlenecks inevitably emerge at massive scale, the path of least resistance, the path to maximum enterprise efficiency, will naturally funnel those corporate customers right back into purchasing NVIDIA's high-performance training and inference hardware.
It's an invisible funnel.
Furthermore, this open-source play is a masterful defensive hedge against the hyperscalers themselves. Microsoft, Amazon, and Google are currently pouring tens of billions of dollars into developing their own custom silicon precisely to escape NVIDIA's brutal 75% margin pricing power.
Trying to break the monopoly.
But if NVIDIA successfully controls the software standard, if every major enterprise on Earth is deeply relying on NemoClaw APIs and NeMo guardrails to keep their business safe, NVIDIA wins, regardless of whose piece of silicon is physically processing the data.
They win either way.
They commoditize the software layer to protect their margins at the hardware layer. They maintain their grip on the ecosystem from the top down rather than just relying on the bottom up.
Well, it really is a Trojan horse. You roll this beautiful, free, highly secure, open source platform into the enterprise. They welcome it with open arms because it solves their security fears. And out pops an absolute reliance on NVIDIA's underlying hardware ecosystem for the next decade.
It's beautifully designed.
But it does raise a wild speculative question about the future of tech infrastructure. What happens if the industry actually achieves true architectural neutrality? If NemoClaw gets so good, and the open source community builds so many efficient bridges and compilers that the software truly no longer cares whose chip it runs on, can NVIDIA really maintain a $4.6 trillion hardware monopoly if the hardware becomes entirely commoditized by their own software?
That is the trillion-dollar question that keeps hardware executives awake at night. If true architectural neutrality is achieved, silicon simply becomes a utility no different than electricity or water.
Just a dumb pipe.
Exactly. The economic value shifts entirely to the orchestration layer and the proprietary models themselves. NVIDIA is making a massive calculated bet that the physical demands of advanced AI are so extreme and the frontier of physics is moving so fast that hardware will never truly commoditize.
There will always be a premium for the best.
That there will always be a substantial premium for the absolute cutting-edge performance that only their engineering teams can deliver. But by aggressively pushing NemoClaw, now they're ensuring a safety net. Even if hardware margins compress from 75% down to 40% due to competition, they still own the connective tissue of the global enterprise.
So we have this massive Trojan horse sitting on the battlefield.
Yeah.
But we have to remember it's not the only framework out there. The AI agent framework battlefield is incredibly crowded, chaotic, and moving at light speed right now. Developers have a sprawling menu of options, and NemoClaw is stepping into a highly contested arena.
It's very noisy out there right now.
Let's do a quick roll call of the major competitors because understanding this landscape is crucial for anyone looking to actually deploy this tech. First up, you have LangGraph. This is a graph-based framework. It is well known in developer circles for very low latency and is fantastic for orchestrating complex branching state machines. If your agent needs to navigate a highly convoluted decision tree with a massive amount of if, then that conditional logic, say a customer service bot trying to troubleshoot a very specific router failure, LangGraph is a heavy hitter.
Then you have Crew AI. Their architectural approach is entirely different. It's focused on role-based collaborative autonomy. Instead of building one massive monolithic agent that tries to do everything, you build a crew.
You assemble a team.
You create a researcher agent, a data analyst agent, and a copywriter agent. You give the crew a high-level goal, and they delegate subtasks among themselves, communicating, critiquing each other's work, and iterating almost exactly like a real human team in an office.
I've seen demos of this, and it's wild. It's literally like spinning up a virtual digital marketing department in 5 minutes. You just watch them argue with each other over the best headline until they reach a consensus.
It's very cool to watch.
Then we have Microsoft AutoGen. This framework is highly conversational. It relies heavily on asynchronous dialogue between multiple agents. It is absolutely brilliant for complex simulation and academic research. Having two AI agents debate an economic topic from opposing viewpoints to find the optimal solution.
Right.
But as many developers will tell you, it has been notoriously difficult to actually put into a stable, customer-facing production environment because the conversations can easily spiral out of control.
They get caught in loops.
Exactly. On the complete opposite end of the spectrum from these heavy frameworks, you have Smolligence, which was built by Hugging Face. This is the minimalist developer's absolute dream.
It's very lightweight.
It is code first.
Yeah.
The entire framework fits into roughly 1,000 lines of code, and instead of relying on clunky JSON API calls to use tools, the agent writes and executes Python directly in the environment. It is built purely for speed and rapid prototyping.
Conversely, if you look at Microsoft's semantic kernel, you see a heavy enterprise focus. It is a .NET-first architecture, highly structured and heavily reliant on complex retrieval-augmented generation, or ORAG, pipelines.
Right.
It is explicitly designed for massive legacy businesses like a Fortune 50 health insurance company auditing claims that are already deeply entrenched in the Microsoft enterprise software ecosystem. It prioritizes strict data retrieval and accuracy over free-form creative autonomy.
And finally, we have to look at the emerging edge cases like NemoClaw. NemoClaw is written natively in Rust, which means it is incredibly efficient and memory safe. It has a microscopic system footprint shipping as a tiny 3.4 megabyte binary and can start up in under 10 milliseconds.
That's insanely fast.
It is not designed for the cloud. It is specifically designed for low-power edge devices. Think about putting a highly capable AI agent directly onto a smart thermostat, a drone, or a medical device running entirely on local hardware without ever needing to ping a cloud server.
It's an absolute buffet of options. It's overwhelming. But here is the true genius of NemoClaw's design interoperability.
It plays nice with others.
NemoClaw isn't necessarily trying to kill LangGraph or AutoGen. It isn't trying to be the only way you build an agent. It has native integrations for Google's Agent Development Kit, Microsoft AutoGen, and AWS Strands. It acts as a universal orchestration and security layer.
So you can use the others within NemoClaw.
You can build your brilliant conversational debating agents in AutoGen, but you run them through the Nemo guardrails and observability suite to make sure they are safe for the enterprise.
That's the key right there.
This is exactly where critical thinking and architectural foresight become essential for anyone building in this space. You cannot just pick the trendiest framework. You have to ask yourself, what does my specific organization actually need to accomplish? You face constant, unavoidable trade-offs between simplicity, execution speed, and complex orchestration.
So how should someone choose?
If you are a lean startup looking to validate a proof of concept over the weekend to show venture capitalists on Monday, you should absolutely use Smolligence. The speed of iteration is unmatched. If you are an academic institution building a deeply complex multi-agent simulation to test macroeconomic theories, LangGraph or AutoGen are appropriate choices. But if you are the chief information officer at a massive, heavily regulated Fortune 500 company, say a global bank or an international healthcare provider, and you are tasked with deploying 10,000 autonomous agents that will interact daily with highly sensitive, legally protected customer data, You cannot rely on a minimalist Python script.
Absolutely not.
You cannot risk a hallucination. You require enterprise-grade security, robust lifecycle management, guaranteed API stability, and ironclad deterministic policy enforcement. That is exactly the massive enterprise void that NemoClaw is designed to fill and own.
So bringing all these massive threads together into a single tapestry. We started by looking at a $185 stock price and a company valued at over $4.5 trillion, raking in $68 billion a single quarter, with margins that defy gravity.
Unbelievable numbers.
We looked at the physical concrete reality of ripping out data centers for 800-volt power systems and installing high-speed Grok infrared chips. We navigated the geopolitical tightrope of 25% export taxes to China, and we traced all of that physical hardware reality all the way up the software stack to NemoClaw,
All the way up.
an open-source platform designed to securely unleash autonomous agents into the corporate world, effectively locking those corporations into NVIDIA's hardware ecosystem for the next decade.
It's a masterful strategy.
It paints a breathtaking, almost intimidating picture of the next 5 years. The physical infrastructure is being laid down right now in concrete and copper, and the software layer to utilize it is being standardized as we speak.
It is a profound synchronization of immense hardware capability and brilliant software abstraction. The agentic revolution is no longer a theoretical white paper concept discussed in research labs. It is a measurable, highly capital-intensive, deployable reality that is currently reshaping capital allocation, physical infrastructure, and enterprise strategy on a global scale.
Which brings us directly back to you listening to this right now. We've talked a lot about trillions of dollars in hyperscale data centers, but think about your own daily workflow. Think about your Monday mornings.
Yeah, think about what you actually do at your desk.
How much of your day is spent clicking between applications, copying data from an email, pasting it into a CRM, generating a repetitive summary report, attaching it to a Slack message, and updating a master spreadsheet?
Too much of it.
Those are exactly the types of repetitive, friction-heavy tasks that a secure enterprise-grade AI claw could execute in seconds in the background. Understanding this shift, moving your mindset from merely prompting a chatbot for an answer to orchestrating a fleet of autonomous agents to execute full workflows, that is the key to thriving in the 2026 economy.
You have to move from being an operator of software to being a manager of digital labor.
Exactly. Manager of digital labor.
And if we extrapolate that exact trajectory, if managing digital labor becomes the norm, it leaves us with a deeply provocative, almost unsettling implication for the fundamental future of human-computer interaction.
Oh, I like where this is going. Lay it on me.
If platforms like NemoClaw succeed in standardizing enterprise security and autonomous agents become truly ubiquitous, if these claws begin executing the vast majority of our daily workflows, talking directly to other companies' agents via APIs, resolving complex supply chain logistics, or negotiating customer service disputes machine to machine at the speed of light entirely in the background, what happens to the concept of the user interface?
The UI itself.
For the last 40 years, software has been explicitly designed to be navigated by human eyes and human hands. We use graphical user interfaces, windows, colorful icons, mice, and touchscreens because humans need visual metaphors to understand digital spaces.
Right.
But if software is primarily navigated, queried, and operated by AI agents rather than people will, the graphical user interfaces and operating systems we have relied on for decades become entirely obsolete. Are we rapidly moving toward a headless digital economy where humans only interact with a single conversational orchestrator and the entire visual web simply fades away into the background infrastructure?
Wow, a completely inevitable digital world. A web built for agents, not for eyes operating on our behalf while we just look at the results. That is something to really mull over on your commute. Thank you so much for joining us for this deep dive.
Yeah.
The agentic revolution is moving at breakneck speed, and we highly encourage you to keep digging, keep questioning the hardware and the software, and keep exploring this material on your own.
It has been an absolute pleasure unpacking this paradigm shift. Stay curious and keep connecting the dots.
We'll catch you on the next deep dive. Take care.